Hello students, next chapter is modern physics. In modern physics we discuss about lasers and optical fibers. First, lasers. The term laser is an acronym for light amplification by stimulated emission of radiation. In this we discuss first light amplification and then stimulated emission of radiation, how to amplify the light and how we achieve the stimulated emission of radiations. For discuss the lasers, we should have knowledge of some basic terms. These are: first is energy levels. Energy level, a definite fixed energy that a molecule, atom, electron or nucleus can have in an compound. We know that an atom consists of nucleus and electrons, and nucleus part is center of atom, which have on positive charge. Suppose this positive charge is nucleus part and electrons revolve around the nucleus in definite orbits. Suppose this is first orbit, n is equal to 1. Then similarly next orbit, n is equal to 2, and so on. We can draw other orbits around the nucleus. So these orbits having definite energies, and these are called energy levels. We can draw these with the help of lines. For example, n is equal to 1, we draw a single line, and for correspondence n is equal to 2, we can draw another line. This is for n is equal to 1 level and n is equal to 2 level. Next is absorption, the process by which one thing absorbs or is absorbed by another. Normally the atom or any substance reside in their ground quantum state, and electron in an atom can be raised from its ground state to higher energy level by the absorption of a photon. In case of absorption, when light falls on this atom, then if this atom gains at any energy from any system, for example a photon falls on electron in n is equal to 1 level, then this raised to higher energy level n is equal to 2. By falling a photon on n is equal to 1 energy level, this absorbs the energy from the photon. This is called absorption. Next is ground level. Ground level is the lowest possible energy level into which a particular system can exist. Considered energy levels E1 and E2 in an atom. Now for n is equal to 1 correspond to E is equal to 1 energy level, and n is equal to 2 corresponds to E is equal to 2 energy level. Now n is equal to 1 energy level is the lowest possible energy level, so this is known as ground state energy level. And in single line diagram, n is equal to 1, this lower energy level is known as ground state level. And the n is equal to 2 is known as higher state energy level, or the process. Next is excitation, the process in which absorption of energy by an electron takes the electron from its inner orbit to some outer orbit of higher energy is called excitation. In case of excitation, when photon falls on n is equal to 1 energy level, this electron gains energy from the photon and goes to n is equal to 2 energy level. This is called excitation, the jump of electron from lower energy level to higher energy level. Next is excitation potential. This, if we apply a accelerating potential which jumps electron from inner to outer orbit, is called excitation potential. If this jump of electron from n is equal to 1 to n is equal to 2 level is accompanied by the accelerating potential, then this is called excitation potential. The energy of an electron in an nth orbit of hydrogen atom. For hydrogen atom, the general energy term is formula is written as En is equal to minus 13.6 divided by n square electron volt, and we put the values of n 1, 2, 3 and so on. For n is equal to 1, the electron in the first orbit have energy is equal to minus 13.6 electron volt, and for n is equal to 2 in second energy level, this value is minus 3.4 electron, and so on. For other levels, energy values can be calculated by putting the value of n in formula first formula. So to get the excitation, to get the energy required to excite an electron from n is equal to 1 to n is equal to 2 level, we have to subtract E2 minus E1, energy between these two levels, E2 minus E1. Then we get the energy is equal to 10.2 electron volt. So we have to apply 10.2 electron volt accelerating potential so that electron is excite from n is equal to 1 to n is equal to 2 energy level. Next is ionization. Ionization, the process of removing an electron from the outermost orbit of an atom to make it an ion, is called ionization. If we have an atom in which the outermost shell is n is equal to 2 and the electron is ejected from here, electron goes out from this level, then this atom becomes an this electron loses an electron and becomes an ion, and this process is called ionization. Next is ionization energy. To the minimum amount of energy required to eject this outermost electron from the outer shell of the atom is called ionization energy. Next is ionization potential. The minimum accelerating potential which is provided to electron just to remove it from the atom is called ionization potential. Next are energy level diagrams for an atom. A diagram which represents the total energy of electron in different stationary orbit of an atom is called energy level diagram of that atom. Now, for example, n is equal to 1 is ground state, n is equal to 2 higher excited state, and so on. N is equal to 3, 4, 5, 6 and up to infinity. There are different energy levels. Now, if electrons lose its energy by coming from n is equal to 2 to n is equal to 1 energy level, or n is equal to 3 to 1, or 4 to 1, or from infinite to 1, then we get a Lyman series, and Lyman series produces in ultraviolet regions. Then the photons released from this is in ultraviolet regions. Similarly, if energy is released, photons is released by by lowering photons from n is equal to 3 to n is equal to 2 level, or 4 to 2, 5 to 2, and so on, then we get Balmer series, and this is in visible region. Similarly, for others, there are Paschen series which releases IR rays.